Okay, here we go with another topic. Now we're going to talk about operations with exponents. So we're just doing more exponent talk, and we've actually done some of this already, but by the end of this lesson, we should all be exponent experts. So let's take a look at some exponents. What if you had x squared, x cubed? What are you doing with those two numbers? Well, there's nothing written in between them, but I think you know that you're multiplying those together when they're written right next to each other like that. So it's really like x times x times x times x times x, isn't it? And that's pretty easy because you know that when you've got 5 x's all being multiplied together, that the answer is x to the 5th. We're going to look at a shortcut so that you don't have to, when in doubt, write it out on this problem. So here's another example. If you have n to the 4th times n to the 6th, you've got a whole bunch of n's. How many n's? You've got 10 of them, don't you? Interesting. You started with 4 n's and 6 n's, and you ended up with 10 n's. And then on the one before that, you had x squared, x cubed, and you had 5. And it happened there too, didn't it? Well, the rule is, what do you do with the exponents? You add them up in this scenario. 4 n's and 6 n's mean you have n to the 10th. And 2 x's and 3 x's mean you have x to the 5th. Now, you can write out all those n's or write out all those x's, but the point of this rule is that it's a shortcut. Okay, it's a shortcut to help you save a little bit of time and effort. So, we can use that on a difficult problem like this to kind of look and see how many d's we have and how many p's we have. We're going to end up having d to the 5th times p to the 6th, and here's why. If you when in doubt, write it out. The d cubed is d times d times d, then the p squared is p times p, then the d squared is d, and then the p to the 4th is p times p times p times p, and how many d's do you have? 5. How many p's do you have? 1, 2, 3, 4, 5, 6. You've got d to the 5th, b to the 6th. So, another example problem. Same idea. You know that that 2 was a 2 to the 1st power, right? So, when it didn't have an exponent there, it's still a single 2. So, how many 2's do you have here? Well, you've got 4 2's, so it's 2 to the 4th. And again, what did you do with the exponents? You added them up. Okay, not a difficult rule. You're adding exponents here. Of course, when you have 2 to the 4th power, you can do 2 times 2 times 2 times 2, and you could probably make your answer 16. Here's your chance. What do you get when you have y to the 4th times y squared times y to the 1st power? Simplify that. Okay, how about when you have multiplication going on, but it's like x squared, and you're squaring x, but then you're taking whatever that comes out to and cubing that, and it's like a power of a power. Interesting, huh? Well, when in doubt, write it out. To cube something means you times it by itself and then times it by itself again. So this means you have x squared times x squared times x squared, right? Because it's x squared cubed. And then each one of those is x times x times x times x times x times x. And how many x's do you have right there? You have x to the 6th power because it's 6 x's. And what do you notice about the 2 and the 3 and the 6? You're not going to add the 2 plus the 3. You're going to multiply them together to give you the 6. So when it's a power of a power, you multiply the two exponents together. Okay, that's not too bad. So try it on this one. If you have y to the 8th to the 8th. Yeah, okay, that makes sense. Now I want to give you a challenge to see if you really can handle your exponents. Are you an exponent expert or not? Let's find... Oh my heavens, look at that thing. What in the world are we going to... Okay, well, I know what 5 minus 2 is. I know what the square root of 9 is. Maybe I could make sense of this problem and persevere in solving it by changing the 5 minus 2 to a, and then changing the square root of 9 to a, oh, okay. Try it and see what you get. If you can handle this problem, you are super amazing. That's all we got. So we're going to work on this some more in class, and we're going to be exponent experts. See you later.